Hello students, welcome to my lecture. In this lecture, I will discuss a question from the modern physics topic. The question as follows. A beam of monochromatic light is used to excite the electron in lithium double plus from the first orbit to third orbit. The wavelength of monochromatic light is found to be. So, they want to excite an electron from n equal to 1 to n equal to 3 state. They want to excite the electron from n equal to 1 state to n equal to 3 state. Then what is the wavelength of light which is required, or photon which is required from outside? What is the photon wavelength that is required from outside? Okay, so we require the wavelength of that. So for that purpose, first of all, you calculate what is the energy here in the first excited state, first state, that is ground state, and the n equal to 3 state. So if I get these answers, then we can determine the difference. So we know that key energy formula in an nth orbit is E1, that is 13.6 multiplied by z square by n square. So for n equal to 1 state, it will be, so don't forget it is a lithium. So what is the atomic number of lithium? So Z equal to 3. So it will be 13.6, Z equal to 3 means 9, 1. So that is 13.6 into 9 here. Then what about here? So 13.6, so n equal to 3 and Z equal to 3. So 9 by 9, 1, that is 13.6 electron volts here. Okay, so let us take the subtraction of these two. Obviously, if I look here, the subtraction comes out to be 8 into 13.6 electron volts. What is the wavelength corresponding to this? The wavelength lambda will be equal to 1242 in nanometers. I'll get answer, that is 8 into 13.6 nanometers. So 1242 divided by 8 comes out to be, comes out to be around 11.4 nanometers. So nano means 10 power minus 9. So it can be written as 114 10 power minus 10 meters. Okay. So whenever there is a problem like this, first of all you determine the energies. Once you know the energies, wavelength can be calculated. Say wavelength in nanometers will be is equal to 1242 divided by energy, that difference in the energy whatever we got, in electron volts. So this is the standard formula you can use to calculate the wavelength of the photon corresponding to that energy. I hope it is clear. So thank you for watching my lecture. Please subscribe my channel and don't forget to like and share.